So let's do some quadratic regression. Recall that the equation of a quadratic is y equals ax squared plus bx plus c. We are concerned with the coefficients a, b, and c, primarily when we're working with regression. So let's look at an example. Okay, so a meteorologist creates a parabola to predict the temperature where x is the number of hours after midnight and y is the temperature. So we want to write a function, and it's going to look like y equals ax squared plus bx plus c. Okay, so here we have some x's and y values. So let's go ahead and put those in our calculator. So we have the x values are 0, 4, and 24, and the corresponding y values are 9.6, 0, and 0. So now let's take a look at the TI84 calculator. The way we can put these in our calculator is we're first going to look for the stat menu right here underneath delete. When I press stat, it brings this menu up. The very first one is edit. So I'm going to press enter because I want to edit my list. L1 will be the list of all the x values, and L2 is the list of all of the y values. So I'm going to go ahead and input all of the x values under L1 and all of the y values under L2. Okay, now that I have them all input, notice that this 0 corresponds with this 9.6. This 4 corresponds to this 0, just like we had in the graph. Okay, so now I want to calculate my regression. What I'm going to do is I'm going to press stat, and notice over here to the left, to the right of edit is calc. So I'm going to hit the right arrow to get to that menu. Now I want to do a quadratic regression. So I'm going to go down here to number 5 that says quad reg and press enter. So it's asking me, where did I store the x values? Well, if you recall, we stored the x values in the first list and the y values in the second list. So we can just arrow all the way down and ignore all this other stuff, and then we're just going to go to the calculate menu. So when I press enter, it gives me A, B, and C. It also tells me what the generic function is going to be, ax squared plus bx plus c. So A is 0.1, so my equation is y equals 0.1 x squared. B is negative 2.8. So this is minus 2.8x. And C is 9.6. So plus 9.6. And this is the regression equation that will model this situation. Now it's asking, how many hours of midnight will after midnight will the temperature reach its minimum? We want to know the x values. It says how many hours after midnight. Recall that x was hours after midnight and y was the temperature. So this is asking us for the x value of the vertex. So the x value of the vertex, recall, is the equation negative b over 2a. So here, b is negative 2.8. So negative b would be negative 2.8 over 2a, and a is 0.1. So if I put that in my calculator, here's what I get. I get 14 hours. And the graph, actually, it looks like this is around 14. So I know that I did it correctly. The second part is asking me, what will the temperature be at its minimum? That's asking me for the y value. So to find the y value, what I'm going to do is I'm going to take this x value here, 14 hours, and substitute it in for x. So y is equal to 0.1 times 14 squared minus 2.8 times 14 plus 9.6. So what I get is negative 10 degrees. So that is the answer to the second part. Okay, so here's another question. NASA can create a weightless environment by flying a plane in a parabolic path. The table shows the heights, h, in feet, of a plane t seconds after starting the flight path. Okay, so first, the values that are listed first are typically going to be the x values. The heights, the value that's listed second, is going to be the y values. So I am going to say that h equals at squared plus bt plus c. Now this is the same as saying y equals ax squared plus bx plus c. So just for simplicity's sake, let's write it like that. So x is going to be the time, and y is going to be the height. So we can put these values into our regression equation. Okay, so to do that, I'm going to press Stat. I'm going to go to Edit. Now I still have the values from my previous try, so I'm just going to delete those and delete those. Now, let's put the x's in L1. So 10, 15, 20, and like magic, it's done. Now you have to make sure that the x value corresponds to the correct y value. 10 corresponds to 26,900, and it does. Okay, now we need to calculate the regression equation. So I'm going to press Stat. I'm going to go to the Calc, and I'm going to go down to Quad Reg. Now we put our x's in the first list and our y's in the second list. So we can just go down to calculate. Okay, so our x values are negative, or rather our coefficients are negative 11, 700, and 21,000. So our regression equation is y equals, forgot already, negative 11x squared plus 700x plus 21,000. Okay, this is the regression equation. So the question goes on to ask, after 20.8 seconds, they begin to experience a weightless environment. I guess it's not asking us for the height after 20.8 seconds. But if we wanted to, what is the height if x is 20.8? Well, we'll just plug that into our equation. Negative 11 times 20.8 squared plus 700 times 20.8 plus 21,000. So the height after 20.8 seconds is 30,800.96 feet. Now it didn't tell me how to round, so I'm just going to round it like that. Oh, what is the approximate height of the plane after 20.8 seconds? Well, we figured that out. When does the plane reach its maximum height? When implies that we are looking for an x value. When does it reach its maximum height? So since this is a maximum, we're talking about the vertex. So this is asking us for the x-coordinate of the vertex. So I've copied down our equation again over here. Now the x-coordinate of the vertex, we use the equation x equals negative b over 2a. Well, this is negative. B is 700. And a is negative 11. So negative 700 divided by 2 times negative 11 is 31.8. And this is seconds. So the plane reaches its maximum height after 31.8 seconds. So now the third part of this question was asking us, what is the maximum height? In other words, it's asking us for the y coordinate of the vertex. So y equals, well, I know the x value. I just calculated it. So this is negative 11 times 31.8 squared. We're using this equation up here, plus 700 times 31.8 plus 21,000. So the maximum height is, and so the maximum height is 32,136.36 feet. Okay, let's check out another one. This table shows fuel efficiency for a vehicle traveling at different speeds. So x is the speed and y is the miles per gallon, or the efficiency. The miles per gallon. So we'll go ahead and put these values in our TI84. Okay, so to do that, we'll go to Stat, Edit, and I'm just going to go ahead and delete all of the values that are already in there. What happens if you accidentally delete a column? There's a way of doing it, I swear. I accidentally deleted L1. So now I only have L2 and L3. Well, that's okay. We'll just put our X values in L2 and our Y values in L3. So now that I have all of the X's and Y's input into my calculator, make a note that X is in L2 and Y is in L3. So when we calculate the regression model, we press Stat, we'll go to Calc, and we'll go down to the Quad Reg. And now the x's are in L2. So recall down here, look down here in blue, above the number 2, you'll see the L2. So I'll press second and 2 to change this to the list 2. The y values are in L3, and L3 is above the 3. So I'll press second, 3, so that now the y values are in list 1, or list 3. So we'll go down and calculate our regression model. So this doesn't say how we'll round. So let's round to the nearest hundredth. So A is negative 0.014. Well, the nearest hundredth is the second decimal place, negative 0.01. So the regression model is y equals negative 0.01 x squared. B is 1.366. The nearest hundredth would be rounding this 6 up to a 7. So 1.37. So plus 1.37x. And C is negative 7.144. The nearest hundredth is this 4. The number to the right is less than 5, so we'll keep that as a 4. So this is our regression equation. So the first part is asking us to estimate the miles per gallon. So we're looking to estimate y for a car traveling at 52 miles an hour. So we want to know y, and x is 52. So we'll go ahead and substitute 52 into our equation. And when we put this in our calculator, what we get is 37.06 miles per gallon. That is the efficiency of a car traveling at 52 miles per hour. Now, what is the most efficient speed to drive? Well, the most efficient speed. Well, the most efficient means that we're looking for the vertex. And what is this asking us to find, the x value or the y value? Well, speed is x. So this is asking us to find the x coordinate of the vertex. The way that we do that is with this negative b over 2a. So b is 1.37. So negative 1.37 over 2a. A was negative 0.01. And so the most efficient speed to drive is 68.5 miles per hour. Okay, that's all. Thank you very much.